Okay, the last mechanism of this type that we've been going over in this lesson is the conversion of the ester to the amide. Now, esters cannot be used to make acyl chlorides or acid anhydrides because those are chemically less stable. You can't do that. But amides are more stable than the esters, so we can use esters to make amides. You also can use esters to make carboxylic acids, but any of them can make carboxylic acids through hydrolysis. So the only one that is of any usefulness to us is to take an ester and react it with an amine to make the amide. So the most reactive esters tend to be the methyl and ethyl esters. I'm going to use a methyl ester because it takes less effort for me to draw, and you know me. Less effort is what I enjoy. So here's an ester. And so we've got a little bit maybe more versatility. I'm going to give us a primary amine. You can do this with a secondary amine, but you don't want to do this with a tertiary amine. You've got to have a proton that you can remove. So make sure that the amine you are using is either primary or secondary, not tertiary. Now, if these two are neutral, again, we're thinking about acid-base chemistry. The amine is an okay base. It's okay. It's the best base for a neutral molecule. And the ester is kind of neither. But acid-base chemistry isn't favorable. So we're going to do electrophile-nucleophile chemistry. And this nitrogen will act as the nucleophile toward the carbonyl carbon, and we will break the pi bond. So we're going to make ourselves a nice little tetrahedral intermediate. Alright. So we're redrawing this tetrahedral intermediate.
You and I, at least, always be good friends.
I'm sure we shall.
Okay, and as you can see, it's neutral because I started out with two neutral molecules. This might be a good comparison for some of you, since I started out with something that was done in base, and then I did one that was in acid, and now I'm doing one that is neutral. At this point in time, what you're going to do is a proton transfer through solvent. So the solvent in this case literally is the amine. You don't need to show this step, but I'm going to because I know some of you need me to show you. So here is this nitrogen. It is the amine. And it's got its lone pairs. And it will come in here and deprotonate this nitrogen and give electrons back. So this is the proton transfer to solvent.
All that land to the left of us belongs to Rosie's mark.
Oh, Lady Catherine, very rich.
I believe so, I believe so. And she has many favors in her gift. Your sister has made a fortunate alliance. Yes.
And what we're going to do now is the proton transfer from solvent. And literally, it could be the negatively charged oxygen, the oxygen attached to the methyl group, or the nitrogen with the lone pair that picks up this proton. Any one of those three groups can do it. But in order to show you productive chemistry, we want it to be the oxygen that's attached to the methyl group that picks up the proton, because we're going to need to have a good leaving group. And right now we don't have a good leaving group, so we've got to make one. That's why we're giving it to this particular oxygen and not one of the others. Okay, so that's the proton transfer from solvent. So if you wanted to, you could have just said PTTS and directly drawn what I'm drawing right now, which will take me a minute to do.
I am happy to see you.
The staircase, I felt myself, is eminently suitable for a clergyman in my position, being neither pushed out
And then we've regenerated our solvent down here. It's not real important, but still there. Didn't go anywhere. Alright, now at this point we want to reform the pi bond and kick out the best leaving group. Well, the best leaving group at this moment in time is going to be the alcohol group. Okay, and that's a weaker base than what we start with, so we're going to do that. Now, as a result of all of this chemistry, hooray, we've made the amide. In this particular case, we made a secondary amide, okay? And you could do this with a primary amine. If you wanted to have a nitrogen with two alkyl groups attached to it, you would have started out with a secondary amine. But again, if you try to use a tertiary amine, it isn't going to work. So don't do that. You won't have a proton that you can deprotonate when you need to do the proton transfer through solvent if you do that. Now, this is the most stable of the carboxylic acid derivatives. So you cannot use an amide to make an acyl chloride, an acid anhydride, or an ester. It's impossible to do that directly. You can take an amide and react it to make a carboxylic acid, and we will show you how to do that. But you can't make the others directly. All of them can be used to make the amide, but you can't go backwards.